Hello all, I am Dr. Pravas. In today's class, we'll discuss about one more examples of liveness analysis. Okay, so we have already discussed about the liveness analysis, the basics of the theory of liveness analysis in the previous classes. Okay, so here we'll discuss one more example of liveness analysis. Assume that assume that all operations assume that all operations take their operands from register. Take their operands from register. What is the minimum number of registers? What is the minimum number of registers needed to execute this program without spilling? This is very important. Without spilling. So means the question generally asks what? How many minimum number of registers means needed to execute the given what program, okay, but without spilling. So just try to understand what is the meaning of spilling. Spilling means what? Suppose spilling means one extra means a register, or we can say one temporary register. Suppose like C equals to A plus B. Suppose here we assign R0 means A will store A in R0 and will store B in R1. Okay, we'll add what? R0 and R1 will then store in one temporary variable like T1. That means this concept is called as one extra temporary variable. One extra temporary variable. Okay, so the extra temporary variable is called as what? Spilling. It's called as spilling. Okay, but we'll try to manage the minimum registers. But say if we'll use without spilling concept, so what happens here? Suppose C equals to A plus B. So we'll store A in R0, we'll store B in R1. We'll store A in R0 and B in R1. We'll add both R0, A and B. We'll add both A and B. Then after adding A and B, then R0 and R1 both are fixed. So we can use any one register. Okay, either R0 or R1. Suppose we'll use R0 here. Okay, but here we use one more extra temporary variable. This is called spilling. But here without spilling means we will try to manage the minimum number of registers. Okay, so this is called as the concept of spilling. Okay, see here, this is one of the code. So we'll try to solve this. We'll try to solve this problem within the minimum number of registers. Let's see the minimum number of registers. Okay, first we'll store this A equals to 1 in R0. Then we'll store B equals to 10 in R1. Then we'll store C equals to 20 in R2. Okay, so then the next statement, come to the next statement. D equal to A plus B. Let's see. A value is stored in which value? Sorry, which register? R0. The B value will store in R1 register. Okay. A value is stored in R0 and B value stored in R1 register. Okay. After adding R0 and R1, after adding the value R0 and R1, then we'll store in B. So which register will use? Just say, first we'll try to, because without spilling, here concept is without spilling. That means we'll try to manage within R0, R1, R2. If there is no option, we can add one more register. If suppose there is no option, means all variables or all registers are live, we can use one more register. We'll try to see, but first we'll see first we'll consider R0 register. R0 register, A is stored in R0. First we'll check this A value. This A value is live or not. So here R0. R0 stores which value? A. If A is live, we cannot use the R0 registers in future. If A is dead, but if A is dead, we can use R0 register. But see, how to check the live and dead? The live and dead analysis we have already discussed. See, where is A on the RHS part? There is no A, 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 there is no A. So we will not use anymore R means A value. That means since A is not present on the RHS part, A is not present in the RHS part, so A is dead. Means R0 register is A value is dead, we can say, or we can use the R0 register. R0. Okay. So in this way, we'll try. So C value means what? R2 register. D value means R0 register. C value means R2 register. D value means R0 register. Okay. C plus D will add. So now we'll try to analyze what R2. First we'll check R2. Just see R2 stores which value? C value. R2 stores C. Where is C? Yes, one more C is here. One more C is here. But there is no new definition. Since there is no new definition, so that means R2 is live. Okay. Then we'll check R0. Then we'll check what? R0. R0 contains what? D. Okay, we'll check D. Where is D? There is no D. There is no D. There is no D. Yes, one more D is here. One more D is here. But above of the statement, there is new definition, means D is on the LHS part. That means R0 D is dead. Since D is dead, so we can use R0. We can use here R0. Okay. Just see. C value. C value stores in R2. E value stores in R0. Okay. Now we'll check. So R2 and R0 both will use here, but we'll check only R1. Now recently we use R1 what? B. So we'll check. So B is live or dead. Okay. Let's see. There is no B. S one B is here, but S there is new definition. That means B is dead. That means we can use R1 register. Here we can use R1 register. Okay. So then R2 and R0 again we'll use here R2 and R0. Okay. Now we'll check. So R2 stores here what? C value. R2 stores C value. So now we'll check. So R2 is free or not? Okay. So C is, if C is dead, so R2 is free. R2 will be free. So check C. There is no C. There is no C. There is no C. That means we can. C is dead here. C is dead means we can use R2. So R2 help. So we'll store R2 for B. Then F will use R1. Okay. Now, so BF. So we'll check. So now R2 contains what? Now R2 contains B. Now R2 contains B. So B is live or dead. This is important. So just check. There is no B. Since there is no B in the below of the given statement, that means B is dead. That means R2 is, we can further use R2. So here R2. Okay. So we'll use R2 here. We'll use R2 here. Okay. Now we'll check for 5, which variable? R1. Yes, we'll use F R1. R1 is free or not? So then we'll check R1 contains what? F. Where is F? Yes, one more F, but there is no F on the LHS part. That means R1 is live. F is live and R1 variable will use. So now we'll check R2, R1, then R0. We'll check for R0. Now recently R0 contains which variable? E. E. But there is no E on the RHS part. That means we can use R0 here. We can use R0 here. Okay. So R0, R2. Now we'll check which variable is free. So see R2. Now recent R2 contains what? R2 contains E, but there is no E on the RHS part. Since there is no E on the RHS part, so we can, means E is dead, so we can use R2 here. Okay. So D means R2. F means what? R1. Okay. So finally, how many registers will use here? R0, R1, and R2. So minimum number of registers are how many? So minimum number of registers is here 3, because here R0, R1, R2. We'll try to solve. Here we just solve this problem within 3 number of registers. In this way we can solve. Okay. Now we'll see one more example. Just say how many minimum number of registers? How many minimum number of registers are required to execute the syntax tree? This is one of the given syntax tree. So how many minimum number of registers will it require? Okay. Let's see how to solve this type of problem. First we'll solve this in the left side. We'll assign R0 to A, then we'll assign R1 to B. Okay. Then we'll subtract both, means A and B. Then we'll store what we will store in any one register, so just like R0, just like R0. Okay. So now this one is over. Now this one is over. So now R1 is free. Now R1 is free. So we can use R1 for C. R1 for C. But D, can you use R0 for D? No, we cannot use R0 because the subtraction, this part means the subtracted value between A and B, the store in where? R0 register. Because R0 contains here, R0 contains what? A minus B value. R0 contains A minus B value. So we cannot use R0. So we have to use one more register, like what? R2. We have to use. Okay. Now, so then we'll add C and D. So then we'll add this part. So we can use R1 or R2. We'll store here R1. Means R1. Here we'll store R1 register store the value like what? C plus D. That means R2 register is free now. So now R2 register is free. So we can use R2 register here. R2. Okay. So R0 contains, that means R2 contains what? E. Okay. So then so R2 and will operate this one, this subtree. But R2 and R1. R1 contains C plus D value. R2 contains E value. So finally, we can use any one registers between R1 and R2. I'm using R1. Okay. So finally, R1 contains which one? Which value? E minus C plus D. C plus D. Now R2 is free. Now R2 is free. Okay. Now R2 is free. So R0 contains what? A minus B. R2 contains E minus C plus D. So then we'll operate the whole syntax tree. Then we can use any one like R0. I'm using R0. In this way, we can solve the syntax tree. Okay. Thanks for watching. In the next class, we'll discuss about the fourth generation. Okay, thanks for watching.